Hello friends, today we are going to learn about Google Cloud Armor. We will understand what the service is, how and when it is used, and we will have a practical hands-on demo about how to configure the Google Cloud Armor service and various other things in there. So before we get to that, let's try to understand what Google Cloud Armor is, what are the key concepts behind it, and we will go from there. So let's get to it. So what is Google Cloud Armor? Okay, in simple terms, Google Cloud Armor is a security service that provides defenses or protects your workloads against distributed denial of service attacks and various other application attacks like SQL injection, cross-site scripting, local file inclusion, remote code execution, in PHP injection attacks, or fixed session attacks, all sort of attacks that your application or your web application may face as a threat. It helps you protect your system your workload against it, and it does that by offering you a rich set of web application firewall rules. If you do not understand what the WAF rules are right now, it's okay. They will be more clear to you as we do our practical demo. But right now, just understand that this particular service, Google Cloud Armor, it's part of the security service that provides or that protects your workloads, your external workloads against various different attacks, like DDoS attacks or application attacks. It supports external load balanced workloads. So anytime you have a web application that you have exposed to the internet and you have exposed it via a load balancer which is external, you can apply these Cloud Armor policies on your load balancer, and then you can create tons of rules based on how you want to protect it, and that's how you can protect your workloads. So that's what Google Cloud Armor service in a nutshell does for you. Now let's understand some key concepts in Google Cloud Armor. Okay, this is good for you to understand because it will help you in the practical demo, or it will also help you to explain what makes Google Cloud Armor, right? What are the different components involved into Google Cloud Armor, right? So first component is security policies. Then there is something called rules language. Then there is something called preconfigured WAF rules. There is also a concept of named IP addresses list, and there is another thing called Google Cloud Armor adaptive protection. So let's go through each of them in little bit of detail to see what are these things. Okay, so let's understand what security policies are. So security policies are sets of rules which allow you to match the attributes from layer 3 to layer 7. These are OSI layers. We will not go into detail what each layer is, but it is good to know, at least have some basic understanding of OSI layers, and for that you can obviously just go to Google and just type in OSI layers and read about them. OSI model, OSI layers, and they will tell you what each layer is. But for your understanding, understand that layer 7 is HTTP layer, or you can call it application layer. That is where you can access your HTTP attributes, and each layer exposes different set of attributes, so you can write your rules to match on different types of attributes of the request. Each rule is evaluated with respect to the incoming traffic, as in incoming request. So you make a request, a rule gets evaluated, either the rule says it's okay, particular request is not violating the security rules that we have and it is okay to pass, or it will say no, it looks like you may be trying to do something goofy here and I will not let you do that, and it denies the particular request. So we will understand how that works when we actually do the hands-on demo. But just understand that security policies are set of rules, and you apply particular security policy or policies on your external load balancers. Security policy rules are like conditions, you can put match conditions, and you can say when a particular attribute matches this particular condition, then take an action. That particular action can be allow or deny. So you can say if this particular attribute matches this particular condition, then allow the request or deny the request. And when you say allow, the request will go through to your load balancer and to your application layer and all that stuff. But if you say deny, then that request will not make it way through to the load balancer and to your application, but it will return whatever response code that you set. All that stuff can be set as part of the rule. Now rules can have two type of conditions, simple and advanced. Simple conditions can be match IP address, a particular IP address, or match range of IP address, CEDAR block of IP address. And you can create whitelist or blacklist rules, which technically are allow or deny rules, and you can set your rules that way. Or you can create custom rules, advanced rules, which use a custom rule language. That rule language is not difficult. It basically looks like regular expression conditions. So if you know a little bit about regular expression conditions, expressions, then you will be okay with that. But they're not very complicated. You can make them complicated. You can write tons of expressions in a rule set or in a rule, but it's all up to you, right? So that's where in the custom rule, where you can set all kinds of stuff. You can match the attributes of the incoming traffic, maybe URL path, request method, request header values, request parameters, query strings, all sort of stuff you can match, and based on that you can take the action whether to allow or deny. And when a particular incoming request matches a condition in the security policy rule, it allows you to either allow that particular request, deny the particular request, or redirect the request to somewhere else. So you can do all sorts of stuff. We will understand about the rules, how to write them in the upcoming demo. Now that we understand what security policies are, the next obvious thing is to understand what makes up security policies, which are security policy rules, right? So let's understand them. Rules are, like I said in the previous slide, are the ones that determine if the request will be denied or allowed or redirected, right? So in order to write those rules, you need to understand rules language. It's not very difficult to understand the rules language. There is a URL at the end here. I'm gonna post this URL in the description of the video, so you can go to this particular URL and understand what makes a rules language, right? But in theory, rules language allows you to write rules based on which you can deny or accept or redirect a particular request. Attributes can be matched in the rules expression, and operations can be performed on the attributes as part of the expression. So you can put and, or, has sort of conditions, matching conditions in there. Multiple operations, you can perform multiple operations in a particular rule. Example is, if you want to say that I want to allow traffic only from one particular IP address CW block, which is 9.9.9.0/24, then you can create a rule expression like in IP range origin.ip. Origin is one of the attribute. IP is a property of that particular attribute, and you can say if the origin IP of my incoming request is within this particular CW block, then allow it, otherwise deny it, right? So that's how you can create a rules language. So if you go to this particular URL, you can see what other things you can do with the rules. Okay, now that we understand rules language, let's understand what are the rules, right? That's the next logical step. So Cloud Armor comes with pre-configured WAF rules. Luckily, you do not have to write your own complex WAF rules to match the signatures of the incoming request and identify the threats and all that stuff. Google offers these rules as is. There is an OWASP mod security core rule set at the coreruleset.org URL. You can go and visit that, and what Google has done is they have taken those rules as is and offered them as a part of the Cloud Armor. So you can just say, hey, match the signature for this particular rule set, and that is all you need to do. You don't need to implement your own ways of implementing those rules, right? Makes it very easy. The pre-configured WAF rules are available for use in Cloud Armor policies. Those rules are SQL injection rules, XSS attack rules, local file inclusion rules, remote file inclusion rules, and so on and so forth, right? So you can read the whole set of rules here, right? And if you want to learn more about the rules and the rule set and the expression IDs and all those kind of detailed stuff, then you can go to this particular URL where you can read through all of that and educate yourself. So good to at least visit both of these URLs at least once to understand what these WAF rules are, what sort of protection they provide, and what do they include, and what makes up a rule set, expression IDs, and all those sort of detailed stuff, right? So that's for the pre-configured WAF rules. Okay, the next thing we want to understand is named IP address lists. Why do we need that, and what is it? Okay, so assume a scenario where you have a load balancer and you have an application behind the load balancer, but you only want to allow traffic from CDN, right? CDN networks like Fastly or Cloudflare or Imperva or something like that, right? So if you only want to allow traffic from these famous cloud providers rather than from everywhere else, and if you have set up your application in such a way that traffic first goes through Cloudflare, and from there it hits your load balancer, and then from there it goes to your application, right? In that case, you want to only allow IP addresses from Cloudflare, right? So that's what you do. Instead of maintaining the list of IP addresses that Cloudflare uses, you can just use you can use these pre-configured address list which Google provides and maintains, so you don't have to maintain it. And whenever there is a new IP address available on one of these services, or when they start using new IP address, you don't have to worry about making changes to your WAF rules, right? The list is maintained by Google, so you can assume that it will be updated, right? So that's what these named IP address lists are. Right now there are 3 providers: Fastly, Cloudflare, and Impera. So these are the three providers which are providing the list of IP addresses. In future it may change, but that's what this IP address list is, named IP address list is. Okay, so now we will learn the last concept, which is adaptive protection. What does it mean? So hackers come up with new ways to compromise your website, right? If you ever wish that there was a way that a service which learns the new ways that people are exploiting your website and then adapts to figure out how does it protect your website, right? That is exactly what Cloud Armor adaptive protection service does. It learns from different ways that your website is getting accessed, and it figures out that, okay, this particular activity looks not in par with how your access pattern of your website is. It generates a signature by itself of a potential attack, and it adds that to your WAF rules, right, to block that particular attack or a signature, right? And it does all that without you doing anything, right? So it learns on itself, and helps you keep your website safe, right? So that's the adaptive protection. Keep in mind that this adaptive protection can get a little costly, so before you enable that, when you are just learning this thing, be careful with that. Don't just check box things that you do not really understand how much they will cost you, and it may end up costing you a lot of money, right? So keep your curiosity little in check. Be curious, of course, right? So that's how you learn, but make sure you understand what a particular service is going to cost you, or a particular feature is going to cost you, right? So that is for the adaptive protection. Okay, now that we are familiar with, or at least little familiar with the concepts of Google Cloud Armor, let's understand how are we going to learn it by doing some hands-on. So we are going to set up a demo. We are going to do a demo, hands-on demo, where we are going to deploy an application which is OWASP Juice Shop website. We are gonna deploy that particular website on virtual machine and put that one behind the load balancer. Now the reason why we choose to deploy this OWASP Juice Shop website is because this website is full of vulnerabilities, and it is for you to learn and understand how to mitigate all these vulnerabilities using Cloud Armor, right? This website has nothing to do with Cloud Armor. It's just there in general for you to do some hands-on, right? It doesn't matter if you're using Cloud Armor or not, right? So but since we are using Cloud Armor, we will protect some of the things on the website that you should be able to not do, but you are able to do, and then how we can stop someone from doing all those things using Cloud Armor, right? So we will explore the vulnerabilities on the website, SQL injection, cross-site scripting attack, and all those sort of things, and then we will stop those vulnerabilities. We will fix them, right? I mean, the right way of fixing those things is using the code, right? Of course want to put the Cloud Armor on there, but since this is a test application, we do not want to go and change the code, right? So we want to protect, even though those vulnerabilities exist in the code, we will come one layer up, and we will stop it at the load before even these requests or these compromised vulnerabilities can be exploited by somebody on our website, right? Then we will do some testing, then we will look at logging and monitoring. That will help us understand what to look for, right? When you have some problems, right? Because these rule sets or these security rule sets are very comprehensive, right? Some of these rules can be very strict and they can adversely affect the traffic, incoming traffic, right? So things will stop working when they are not supposed to, right? And how do you troubleshoot that? How do you figure out, okay, what is blocking these legitimate requests from coming in and all those sort of things? So how do you troubleshoot things, right? So we will look all those things in the demo. So we will set up these particular website on virtual machines and we go from there. So I'll see you in the demo. Okay, so it's time to do the demo. We are going to create a brand new project and we will work our way from there. So let's go ahead and do that. So let's go here, it's a new project and we're gonna call it Cloud Armor Demo and we will say create. Ignore my previous attempts here. So we will select this project and now we are in the project. Click on the dashboard. So there is nothing running in this project as of now. So we will go and do things from the UI, but I have also created a script that you can just run on your activate the Cloud Shell and you can run that particular script and it will set up the entire application for you, right? But since we want to not do that and we want to do this from the UI so you can understand the different parts that are involved in setting this up, for that purpose and only for that purpose we are going to do this from the UI. But there is a shell script, you can fetch it from the link which is in the description and that will set up the entire application for you, right? So let's go ahead and do that. I'm gonna close this and let's go. Okay, so the first thing we want to do is we want to create a virtual machine and set up our application on the virtual machine and verify that our application is accessible through a browser on that virtual machine, right? And then we will add it to the load balancer and all those fancy stuff, right? So let's go to compute engine, and if this is the first time you're doing it, it is going to ask us to enable the API and we click on enable and then we wait. Okay, so our compute engine API is enabled. Let's close this. So now we should be able to create a virtual machine here and let's go ahead and do that. Okay, so we click on create instance and we are gonna name this instance as OWASP juice shop. Yeah. Okay, we're gonna leave the region and zone default as is. In the machine configuration we are gonna select the lowest one and scroll down, and then in the container section here we are going to say deploy a container, right? So there is a container provided by OWASP people that we will use, and we are going to host that particular container on our on our system. So let's put the container image in here. It's you can see the what container image is in the shell script that I have uploaded on GitHub, right? We are going to leave everything as is and we are going to just say select, and we are going to leave everything else as is. We are not going to make any changes and we are just going to click on create. What this will do is it is going to set our application on a virtual machine, and we should be able to access that particular application on our virtual machine running on port 3000, right? Now, because this is a brand new project, if we right now just copy this, and if we go to browser and we say HTTP, this guy, it's not going to be able to reach there because traffic does not go there right now. Sorry, port 3000, right? It can't go there on port 3000 because we have not created a rule in the firewall, right? So we need to create a rule in the firewall so that we can reach to our virtual machine on port 3000 from anywhere, right? So we'll say create a firewall rule, and we are gonna name this as allow traffic on port 3000. Logs off or on doesn't matter. Network is default, ingress allow, and we are gonna say all instances in this particular network, and we are gonna say from anywhere, and we are gonna say port 3000, right? And then we say create. So the moment this gets created, it will allow us to visit our website, and you can see that we can access the application. It's an awesome application. Don't use it as a benchmark, but it does the job, right? And it's for learning purpose, right? Nobody will do that for you. These guys have done it, right? So appreciate the effort, and just work with what you have. So now that now that we can access our application, right? Now that we can access our application, what we will do is we are going to put it behind a load balancer, right? So let's go ahead and do that. So from here I will again go to compute engine, and in order for me to put this behind load balancer, I need to first put it, make it as this virtual machine as part of the instance group. So here are the instance groups. We are gonna say create new instance group. We get few options here saying managed instance groups, stateful, stateless, and there is also an option for unmanaged instance group, right? We are going to select unmanaged instance group because we are going to add our existing virtual machine to the instance group, right? So we will just create a unmanaged instance group. So we are going to call this OWASP juice shop instance group, and we're going to leave the region and zone as is, right? And here we will select the virtual machine that we just created, and we say okay. And in the port mapping, we are going to come here, and we are going to call this one as HTTP, and the number is 3000 because this application is hosted on port 3000. That's what we want to do, and we click on create. Okay, now that our unmanaged instance group is up and running, right, and there is nothing to see here except that you can see that this is the virtual machine that is here, one instance, right? What we now need to do is we now need to create a load balancer, right? So we come here and we say load balancing, and we say create load balancer. So here we will select HTTPS load balancing, the first option from internet to my VMs or serverless services, and it will be of type global HTTPS load balancer. and we click on continue. We will name the front end as, we will name the load balancer as OWASP juice shop load balancer, and we will name the front end as FE OWASP juice shop front end, right? And it's gonna be protocol HTTP, port will be 80, and we say done. So now let's go and configure the backend where the requests will be sent, right? So they will be sent to our unmanaged instance group. So we say create a backend service. We're gonna name this backend OWASP juice shop instance group HTTP, map it to the HTTP port that we have created. New backend instance group, we select this, port numbers 3000, leave everything as is, and we create health check. So we say create a health check, name health check OWASP juice shop, and this will go to port 3000. Everything else is good. Click on save. Enable logging. I will tell you why we enabled it. This is to troubleshoot things, which will come very handy. And then we click on create, and then we say okay, and we say create. Okay, so now that our load balancer is created, let's go in there and see what is going on. So our front end is, this is the IP address of our load balancer, and our backend service is this. Go from, whatever request we send will be traffic, will be going to this particular backend service, mapped it to HTTP port, which is technically 3000, and the instances for the load balancer are these unmanaged instance group, right? So let's test this and see if it works. Copy the IP address from the front end and put it up here. Okay, so it just takes a while for the website for the load balancer to set itself up, but once everything is set up, give it some time. If you get an error saying the website cannot be accessed, eventually you will be able to access it. But once the website you're able to access it, you should be able to see it from the IP address here, right? So this is our virtual machine IP address, this is our load balancer IP address. Okay, next we are going to look at some vulnerabilities, exploit them, and then we will fix them. So let's go and do that. Okay, now that our website is up and running, let's do some vulnerability stuff, right? So the first thing we want to do is we want to do some sort of SQL injection, right? So for that we come to account and we say login, right? And we just put some email here and some password, and we say login, and it says can't do, this user does not exist. Okay, well, I have a way to overcome that problem, because I'm a bad guy, right? So I'm a bad person. I know that this website is vulnerable to SQL injections, so I will try to do exactly that. What I will do is I will type in my very simple SQL injection thing, where I will say log me in if anything or true, right? So the first user that it is going to find, it will just log me in like as that particular user, right? I will click on login, and boom, I'm there. and you can see that I am logged in, and I'm logged in actually as an admin, because admin happens to be the first user, right? Not really very good, right? So we technically solved a challenge for SQL, by doing a SQL injection, right? That's what this website is meant to showcase, right? That how do you hack stuff, right? So now that we were able to exploit this particular hack, let's go and see how do we stop that. So let's go and set up our cloud armor, and add the policies and things like that, and let's do that. One thing I would like to point out, that make sure you are doing this from the IP address for your load balancer and not from your app. So I'll just close this tab, right, so that we don't end up making that mistake. And now I will go and set up the cloud armor. So I come to Google Console and I type in cloud armor, and I will open that in a new tab. And you can see this is the first time we are doing anything here. So I will click on create policy. Remember the concepts that we spoke about. You have a policy has rules has expressions, and then you associate a particular policy to your load balancer, right? So this is the first thing, creating a policy, right? We are gonna name this OWASP security policy, right? And the first rule that we are creating, what we are saying is we are going to create it as an allow, right? Saying that allow everybody, right? Because we want this website to be accessed by everybody, right? On the planet Earth. That's our intention, right? We do not want to stop doing that, so we will say allow everybody on this particular website. Okay, and you can see as we start creating more and more rules, you will see that them being displayed over here, right, based on the priority. I'll tell you what the priority means, right? So let's do one thing at a time, right? Policy type, backend security policy, not the edge, because we do not have anything on the edge right now. Everything is a backend, right? Remember, our backend is our load balancer, right? So that's good. Now let's add a new rule, right? So in here I will say prevent SQL injection. Okay, now as you can see here that it is adding new rule here, right? For the mode, remember we spoke about in our theory lesson that there are two modes, basic and advanced. Basic is IP addresses range. You can deny or grant IP addresses can go through or not, or we can go to advanced mode where we can write a rule in the rules language, right? So this is how we write rules language. We say evaluate preconfigured expression, expr, and then we say SQLi canary, right? So there are two types of rules, right? Canary and stable. The difference between them is canary is something that is if Google makes changes to the rules, they first go to canary, and then once they establish that these rule sets and these expressions are good, they are doing what they are intended to do, they move over to the stable expressions, right? A rule set, right? So there are two rule sets, canary and stable, right? So if you want to have at most up to date rule sets, you can use canary, or you can just replace this from canary to stable, and that will work too, right? So we will just do stable. Next thing we want to do is we want to specify the action, right? So we are gonna say deny, right? We want to say that if Cloud Armor encounters anything that looks like SQL injection based on these, pre-configured rule set, deny that particular request, return the response 403, which is forbidden, right? Then you have a checkbox here called enable preview only. What it will do is, if you check this, it will not stop the request from going through. It will just log that particular request in the cloud logging console, but your requests will still go through, right? So this is more like, for testing purpose, right? You don't want to just make changes something to your production system, right? So before you do things in your production, you want to test it, verify that everything works, right? And that's why you want to check this box when you're doing your testing, right? So we are gonna uncheck that. And then comes priority. So each rule that you create has a priority, right? What it means is, higher the priority, higher the precedence of that particular rule, right? So you can see that our default rule that we said allow everybody, has a priority of very low, right? It's a low priority rule, so that it is evaluated at the end, right? Because what will happen is, if we put this rule at the top, and then we define every other rule after that, then those rules will not get evaluated, right? So there is a cycle, there is a chain, the way the rules get evaluated, right? So you want to perform all your checks and balances before you say yes, everybody is allowed. If allowed is encountered first, nothing else will be evaluated after that, right? So you don't want that, right? You don't want the processing to stop. You want process to go through multiple rules, right? So that is why we will create the rules, right? So the priority for this rule, we will set it something like 20,000, right? You want to give yourself some space, right? In case if you come up with different rules, you want to have some room, right? So that you can define more rules with priorities, and you can adjust the priorities, right? You don't want to start with 1, 2, 3, 4, 5, and then you figure out like, oops, I should have done something before I did the first one, and then you will end up making a whole mess, right? So give yourself some room, and work that way, right? So we say done, right? And then we add targets. Remember, our target of our policy is load balancer backend, and this is our load balancer backend. And this is the adaptive protection. It's just a checkbox. You do not want to do that right now. You can do that, but you don't want to do that. Maybe I don't know how much it is gonna cost you, but it's really not required right now. When you're learning, So that's how it looks. So let's go through it one more time, right? So we created a policy. The type is backend security policy. The first rule of our policy is allow everybody with the lowest priority possible, right? And then we added a new rule in here with a deny with a deny action, and we are saying that if you encounter anything like SQL injection, deny that with 403 response, right? And we set the priority of 20,000, right? Now if you want to know what other rule sets can you write in here, then there is a URL that you can go to. Let me get that URL for you, and we can actually look at that together. Okay, I have the URL, and this is how the URL looks like: cloud.google.com armor docs rules rule tuning, right? It's there in the description if you want to grab it. And these are the two rule sets. You can see CRS 3.3 and 3.0. You want to use 3.3 because that's what that's what is recommended, right? 3.3, and it says we recommend that you use the version 3.3 for increased security. And these are the mode security rule names, right? SQL v33 stable, and SQL I v33 canary. You can see XSS, same thing, stable and canary, stable and canary. And I just told you difference between stable and canary is that stable is, you know, productionized rules, you know. Canary are more like, you know, in testing it may have, you know, more rules than what you want, but you know, that's how it works, right? And these are all the rule sets that you can, you know, specify, right? And let's actually fix our mode security rule name. Take it from here, and instead of saying SQL I stable, you will say SQL I v33 stable. And we are going to, you know, so we said done, right? And we applied it to our backend, which is, you know, a load balancer. Did I miss anything to explain here? So we created the rule deny action response code 403, lower the priority. We are just, you know, learning stuff, so we don't really need to, you know, do the debugging, right? So we are going to remove the preview only, and what we are going to do is we are going to click on create policy. Oh, I know. Should be expr and create policy. Okay, so it works now. Okay, our policy is created, and it takes a while for the policy to take effect, right? So what I'm going to do is I'm going to, you know, come here, and I will actually log out, right? I'm gonna close this, and I'm going to log in again, right? And it might take a while for the policy to take effect, right? Probably about 5 minutes or 10 minutes, you know. So I'm gonna keep trying to test it, and when it actually blocks me, I will come back to this. Okay, it has been some time, so let's refresh. Let's refresh and see what happens. Okay, so our rule is working, but we have a problem, right? So this is where, you know, we try to log in, and, you know, right now we are not logged in, right? So right now we are logged out, right? So let's just try to hit the home page, and you can see that we can't even get to the home page now. So that's the problem, right? So at least we should be able to get to the home page, then log in, right? So this is what I wanted to show you. What is happening is, you know, some of the rules in that rule set are too restrictive, right? And that's what they are doing. They are creating a problem, right? So that, you know, our website is not even accessible to people, right? Very counterproductive than what we wanted to do. So what we want to do is we want to adjust our rule and ask it to not evaluate a particular rule expression ID, so that, you know, at least we can get to the home page, and then from there SQL injection should be prevented, right? So how do we know which one of these rule set IDs is creating a problem, right? There are tons of rule set IDs in particular rule set, right? So that's where our, you know, cloud logging comes into picture. So let's go and do that. So we come to our, you know, cloud armor, right, or policy. We click on it, and the easiest way to get to this is we click on logs, and we say view policy logs, and you can see all these, you know, warnings, right? So every time now anybody tries to go to, you know, home page, they can't, right? They're getting blocked. So we expand that particular node, and then we scroll down, and you will see something called enforced security policy, right? we expand that node, and it will say deny OWASP security policy, which what we wanted to see. And we click on here, another one called preconfigured expression IDs. This is the particular expression ID that is blocking our home page. People don't even get to the home page. We want to not do that, and so what we will do is we will ask our rule to exclude this particular expression ID from the entire SQL injection rule set. So now what we do is we copy the value of this particular expression ID, and we go back to Cloud Armor, and we click on the policy. We click on the rule, we edit the rule. Remember, this is the rule we added for preventing SQL injection, right? So we want to edit that. Now here is how you can exclude something, right? So after you say evaluate preconfigured expression and you give the rule set name, you say comma, and then you put an array of the IDs, expression IDs you want it to exclude, right? So you can add more. If you have more expression IDs that you want to exclude, you can do that. Right now we only have one, so this is an array. Remember the syntax, right? So you put a comma at the end, and then you exclude it as an array, and then you put your ID, expression ID in here, and that's all we need to do here. And then we click on update. So now what it will do is it will exclude that one particular ID, rules expression ID, rule set expression ID, and hopefully once that takes effect, we should be able to get to the home page. So again, it's gonna take few minutes, but I will come to it when that is done. Okay, it's been a while, so let's try to do this again and see what happens. We are still getting 403, so let's go and see if something else is blocking. Okay, so we do the same thing, we expand it, and for security policy, preconfigured expression IDs, of course this is a different ID. So we copy the value and we come back to our policy, and we say edit, and this way now you can see how to add two IDs in here, expression IDs. So we said exclude 942420, and we also said exclude 942421. Okay, looks good to me. Let's update this, and again come back after a few minutes, and hopefully once that takes place, it will allow us to at least go to the home page. Okay, so it's been a while, so let's go back to our web page and refresh it. And awesome, now I can actually go to the home page without getting blocked. So these, excluding these two particular expression IDs, working just fine. Now here is the moment of truth, right? So let's see if our SQL injection has been stopped or not. So we come again, account and login, and let me copy this SQL expression and paste it here and put a password, something, click on login. Awesome, look at that, it says 403 forbidden, exactly what we wanted it to do. We fixed SQL injection without changing the code, right? And we used Cloud Armor exactly the way it is supposed to be used for. And that's how, my friends, we can stop SQL injection using Cloud Armor. So our demo is not done yet. What we are going to do is we are going to do more. right? Because SQL injection is not the only thing we want to prevent. We want to prevent XSS. We want to prevent local file inclusion, and all those sort of things. So let's do XSS this time, right? So let's go back to our website and let's do just that. So I will go back to the home page, and let's first create, exploit the XSS vulnerability, and then we fix it just like we did the SQL injection thing. Okay, so let's do cross-site scripting. What we will do is we will go to customer feedback form, and we will add a very simple cross-site scripting. No, before we even do that, let's make sure the normal thing works, and we will just type in nice feedback, and we will give a rating, and the result 8 multiplied by 2 16 multiplied by 7 is 9, and we say submit. And we are not supposed to get 403 forbidden because this is a regular normal feedback. I do not know why we got that. So let's go to Logs Explorer and see what happens here. What happened here? So this is the culprit. Okay, so somehow SQL injection prevention that we did stops cross-site scripting as well. Okay, I did not see this coming. So I'm not going to exclude this particular expression ID from the SQL. Instead, gives me an opportunity to show you guys something. What I will do is I will edit this particular rule, and I will say this is preview only, right? So remember, we talked about the preview only is that it will not stop the request from going through. It will just put it in the log, right, saying this particular request would have stopped if it was not in preview only, right? So we updated that, and what will happen is now when we come here and when we submit this again, it will go through, but it will put it in the logs saying this should not have gone, and then we will do our cross-site scripting challenge, right? So let's wait for it to take effect, and I will come back to it when it's done. Okay, so let's try to submit this feedback one more time, regular feedback, and see if it works. So we will do 16 minus 9 minus 7 is 9, and this is normal feedback. Earlier we got the 403 error. This time we should not get that because we changed the rule from being enforced to preview, right? So click on submit. Okay, at least this is working now. So our feedback form is working, but if we go here and we look at this, we should be able to get an error here saying this should have stopped, right? You can see here preview security policy, these would have been denied, but because we set it to preview, it did not, right? It went through, but you can see it in the warning, right? So that was intentional, right? So now let's go ahead and create a rule where we can actually stop cross-site scripting with cross-site scripting rule set. So what I will do is first we will put a cross-site scripting statement in our feedback and see it go through. Paste it here, and that captcha is too complicated. And 4 minus 9 is minus 5, minus 2 is minus 7. Give the rating submit. Okay, so the feedback went through, right? Even though it was a cross-site script attack, it went through. Now we want to prevent this sort of comment from going through, right? So what we will do is we will come here and we will say add a new rule, and we will say prevent cross-site scripting, advanced mode, and we will say evaluate expression, and the expression name we will take is this guy. Paste it here and deny. Now priority, we are gonna set the priority for this guy to 30,000, right? So what will happen is it will send you deny forbidden 403. This is not preview only, it will actually stop, right? So we will do that and we will click on add, and you can see the order of rules being gonna get evaluated based on the priority. 20,000, 30,000, 20,000 is SQL, 30,000 is cross-site scripting. Now again, let's give it some time so that it can do what it is supposed to do. Okay, so it's been a while, so let's go back to our juice box and try to see if this guy stops our cross-site scripting attack or not. So we will put the comment as our XSS attack, and 6 minus 4 is 2 minus 4 is minus 2, and give the result. Click on submit, and of course you can see 403 forbidden here. Awesome. And you saw the thingies, fire thingies, celebration thingies on the side. Anyways, so let's verify that our cross-site scripting actually is stopping this. So let's go here and expand time and scroll down. There you go. So you can see this one for the preview policy, and this one for enforced security policy. Outcome is deny, and you can see our cross-site scripting policy actually stopped it, right? Instead of saying that SQL injection script, right? So that's a good thing. So now that you know how to stop cross-site scripting, let's do something else. Okay, so this time we are not going to use browser. Okay, so we are actually going to use command prompt, and I'm gonna show you that how somebody can actually get do a local file inclusion attack, right? So for that, I'm just gonna start Cloud Shell here, and let's clear this out and actually open this in a new window. We'll close it here. Okay, now our Cloud Shell is here. You can see it easily. So let's first exploit that, right? So what I will do is I'm going to post this particular curl command over here, and I'm gonna say curl -i, capital I, small I, http:// IP address, and then I'll say list the directories, right? Let's see what the response comes from. Okay, so the response comes 200, right? We do not want 200. We do not want people to actually just do this sort of stuff, right? We do not want people to just list the directories and stuff like that. So what we are going to do is we are going to stop people from doing that. We know what to do. We go to network security and we say add a new rule, and this time we are gonna say prevent LFI, local file inclusion, and again advanced mode, evaluate expression, and the expression we want is this guy. Paste it here. Again, deny 403, and priority we are gonna make this one 40,000. Right? See how we are keeping the gap of 10,000 IDs priority between each rule. So if you need to add more, you always have a ton of room, right? And again, this is gonna take a bit to actually take effect, so I will come back to it when it actually does that. Okay, so I just tested it. It looks like it's working. You can see that previously we were getting 200 okay response, and now we are actually getting 403 forbidden, right? So try it again, try it again, can't do, right? Good thing. So that's how we prevent local file inclusion. Okay, this is the last bit of the demo. So what I want to showcase is how do you use attributes of a request to actually block something, right? So this is what we will do, right? So we have this website here still running. We'll just do /ftp. Oh, good. So what you can do right now, what you can see is you can see everything that is listed over there, right? All the files that we have hosted, right? We do not want that, right? Because now somebody can just say /legal.md, and boom, now they can just grab any file and just read it, or do stuff. We do not want that kind of stuff to happen, right? Okay, so how do we stop that, right? Now this LFI did not stop it from happening, right? So what we want to do is we want to say if the request path has /ftp in it, block it, right? Do not let it go any further, right? So again, let's close the Cloud Shell here, and let's go to the network security, and we say add a rule, right? Prevent FTP, right? We go to advanced mode. Now this time we are not going to write evaluate preconfigured expression, right? Instead, what we are going to say is we are saying request dot path dot matches /ftp, right? Then deny 403, and the priority is 50,000. Right? Now because this is layer 7, right, we can access the parameters that come with the request, right? That's why we are able to do this, so let's send it, and click on add, and let's wait for this to take effect, and once it happens I will come back to it. Okay, so let's try and see if it is working. So we will come here and we are gonna still say /ftp, and awesome, now we can't do that. We are getting 403 forbidden, right? Same thing if we say /legal.md, we get the same thing, right? 403 forbidden. That is how we can prevent people from just grabbing files from our system, right? Our website, right? So this is it. I hope you guys learned something today. I hope you guys will leave some good feedback in the comment section, and let me know what else you guys would like to see, and I will try my best to put it out there. So meanwhile, happy coding, and good luck.